So this is video number 4 of 5.4 quadratic relations in factored form. And so now, we've looked at how to go from factored form into standard form, and that is simply by expanding, and that's not, algebraically, that's pretty easy. And so now we want to know how to go from standard form to factored form. And why would we want to know that? Well, because standard form tells us really just about nothing about the parabola. All you can get out of this form is the y-intercept. And just to know the y-intercept doesn't really help us with anything. I'm just going to do that. There we go. It doesn't help us with anything. I mean, you can have the y-intercept. I just draw a quick graph. Let's say the y-intercept's right here. Well, what do we know? We don't know anything. We don't know if it looks like this. We don't know if it looks like this. We don't know if it looks like that. We don't know if it looks like that. Like, we have no idea what it looks like. All we know is where it's crossing the y-axis. So it is useless. So we want to be able to convert it to factored form, or eventually we're going to learn how to convert it into the other form, which is vertex form. But we want to go to factored form right now because that's the other form that we understand. So how do we do that? Well, let's just take a look quickly at an easy question. So let's say the question was y equals x minus 5x plus 2. All right, we expand that. So x times x is x squared, x times 2 is 2x, minus 5 times x is minus 5x, and minus 5 times 2 is negative 10. So x squared minus 3x minus 10. How does, now I want you to think about this for a second, if you have to stop the video to think about it. How does this form and this, whoops, what's that? What's going on there? And this form, how do they relate to each other? How do these numbers here relate to these numbers here? Think about that for a second. Stop the video if you need to think about it. This is one of the bonuses of having video lessons, is that you don't have to sit. You get time to think. You get as much time to think as you want. And it doesn't get interrupted by somebody else in the class putting their hand up and answering it for you. So think about it. How do these numbers, and look and watch and see how they come about. How do you get these numbers, the negative 3 and the negative 10, based on negative 5 and positive 2? So think about that for a second. All right, well, hopefully you have figured out that I'm going to start with the minus 10. If this is R and this is S, well, I'm not even going to do that. Minus 10 comes about by taking negative 5 and positive 2 and multiplying them. So negative 5 times 2. And then the negative 3 comes about by taking negative 5 and positive 2 and adding them. So we're going to use this fact to be able to convert from this form to this form. So this is what we call factoring again. And this is a specific kind of factoring, and it's called simple trinomial. Simple trinomial factoring. What a simple trinomial is if you notice that this form of the equation, the y equals x squared minus 3x plus 10, there's a value for b, which is negative 3, and there's a value for c, which is negative 10. So there's a b and there's a c, but the value for a appears to be missing. Well, what is that number right there? When there's no number in front of a variable, what is its value? And its value is a equals 1. So this is what we call a simple trinomial. And we want to break it down into its pieces, into its factored pieces. So x minus 5 is called a factor of x squared minus 3x minus 10. And x plus 2 is called a factor of x squared minus 3x minus 10, because you take those two things and you multiply them and they will give you x squared minus 3x minus 10. Just like the number 5 is a factor of 10 and the number 2 is a factor of 10, and you multiply those two and you get 10. Okay, so what we're going to do is we're going to do a few examples. Okay, so these are called simple trinomials. Notice with all of these, the a value is equal to 1. So that a value, a is called a leading coefficient. It's the coefficient on the first term, on the leading term of the equation. So a equals 1. All right, so go back again. We need two numbers here. We needed two numbers that multiply to give us negative 10, which are negative 5 and 2, and they add to give us negative 3. So what we're going to do is we're going to, if you know, see I've got these little x's in here, and in the top you're going to put what they multiply by to get you to. So I'm going to put multiply to give me 20, and they have to add to give me 9. So they multiply to give you this top number, and they add to give you, sorry, not this top number, this last number, and they add to give you the middle number, the middle coefficient. And we need to consider with the multiplication first, because that will limit, like there's an infinite number of numbers that can add up to give us 9. I could take 10 and minus 1. I could take 15 and minus 6. I could take 20 and negative 11. I could take 7 and 2. There's infinite possibilities that can multiply to give you 20, or sorry, that can add to give you 9. But there are not infinite possibilities that can multiply to give you 20. Like, these have to be integer values. Think of the numbers that multiply to give you 20. So multiplying to give you 20, I'm just going to write them down in pairs. We've got 1 and 20. 2 and 10, 4 and 5. We need a pair that are going to add up to give us 9. Well, the only pair here that are going to add to give you 9 are 4 and 5. So then this would have to equal x plus 4, x plus 5. Okay, see how that works? So 4 times 5 will give you the 20. And you can always double check to make sure you've done it right, because if you expand what you've written, now the expanding part is not part of the answer. It's part of just checking your answer. If you were to expand this out, you would get exactly what we started out with. I'm just going to quickly show you. We would have x times x is x squared. X times 5 is 5x. 4 times x is 4x. That's a 5 right there, by the way. It's not a 6. And then 4 times 5 is 20, which gives us x squared plus 9x plus 20. So, yep, we got ourselves back to where we were. Okay, so basically you do all simple trinomials this way. So I'm going to go down to the next one. We'll go to the right in a bit. All right, so this time we're looking for two numbers that multiply to give us 30, and then they add to give us negative 11. So 30, you got 1 and 30, 2 and 15, 3 and 10, 4 doesn't go into 30, 5 and 6, and that's all you got. So we need a combination of numbers that are going to give us negative 11. Now, you have to think about the signage here. For two numbers to multiply to give us 30, either both of the numbers have to be positive or both of the numbers have to be negative. Okay, to multiply to give you a positive value, you need both your numbers to be positive or both your numbers to be negative. But we want them to add together to give us negative 11, which means both numbers are going to have to be negative. Now, the only combination of numbers, 1 and 30, will never give us 11. You can add them, you can subtract them, but they'll never give us 11. 2 and 15 will never give us 11. 3 and 10 will never give us 11, but 5 and 6 will. And in order for them to give us negative 11, they both have to be negative. So then you've got y equals x minus 5 and x minus 6 is your final answer. Okay, this last one on the left-hand side, we got two numbers that multiply to give us negative 36. So remember, it's multiply here, add here. So they multiply to give us negative 36, and they add to give us positive 5. So you think about that. They have to multiply to give you a negative value. So what has to be true about the two numbers for them to multiply to give you a negative value? Think about it. Right, one has to be negative and the other has to be positive. So now, factors of 36, 1 and 36. Those will never give me 5. Never in a million years. 2 and 18. Nope, not going to give me 5. 3 and 12. Nope, not going to give me 5. 4 and 9. Oh, those two could give me 5. I could have a 9 and a minus 4, and that would give me positive 5 when I add them together. And then the last pair is 6 and 6, and they're not going to give me 5. So to get negative 36, so it's going to be 4 and 9, but to give me a positive 5, I need a positive 9 and I need a minus 4. So then that's going to be y equals x plus 9, x minus 4. These numbers that you're coming up with aren't the zero, or aren't the x-intercepts. They're the actual values that are going to go into the brackets. Okay, so now let's take a look at this next one, y equals x squared minus 7x. Well, if you notice, we can do a little bit of common factoring here first. In fact, the whole thing can be all about common factoring. These two terms, x squared and 7x, they both have an x in them. So I'm going to factor an x out, and I'm going to be left with, what do you have to multiply x by to get x squared? You have to multiply it by another x. What do you have to multiply x by to get a negative 7x? You have to multiply it by a minus 7. And you're done. Okay? Now, the other way to think about this is, okay, it's a simple trinomial. I'm going to do this other way in pink. It's a simple trinomial. The number on the end is 0. So that's plus 0 on the end. So they have to multiply to give you 0. And they have to add to give you negative 7. Well, I mean, there's a million ways that you can multiply to give you 0, but to multiply to give you 0, one of them has to be 0, and then for them to add to give you negative 7, 0 and negative 7 add to give you negative 7. So technically, it would be x minus 0 or x plus 0 and x minus 7, so these two numbers here. And we wouldn't write x minus 0, we would just write it as x and x minus 7. I think this is easier to do by common factoring first, because it's just a one-liner. You don't have to worry about doing this, playing the x game. The x game. All right, so next one is very similar to that. If you take a look right away, these two terms both have an x in them, so that would be y equals x, and then an x and a plus 2. All right. And then this last one, it's a little bit special because this time the 9, that's your c value. So the two numbers have to multiply to give you negative 9. Technically, this is x squared plus 0x minus 9, technically. So they have to multiply to give you negative 9, multiply to give you this last one, but add to give you 0. Well, what's the only way two numbers can add to give you 0? Well, that's if they are the same number, but one is positive and one is negative. That's the only way they can add to give you 0. So what two numbers will multiply to give you 9? They're the same number, but one is positive and one is negative. Well, that would be -3 and +3. So then this factors like this, x minus 3, x plus 3. This has a special name, and we're going to talk about it a little bit more later, but all of these simple trinomials, no matter what they look like, whether they have the form y equals x squared plus c, where c turns out to be negative, and let's talk about that for a second. What if we had something like this, y equals x squared plus 9? So then when you go to play the x game, they have to multiply to give you positive 9 and add to give you 0. How could that happen? How could two numbers multiply to give you a positive? So either both are positive and both are negative, but they have to add to give you 0. The only way two numbers can add to give you 0 is if they're the same number, but one is positive and one is negative. Well, the only way you can have two numbers where one is positive and one is negative multiply together is if they multiply to give you a negative. This kind of question is not factorable. You cannot factor that. There's lots that you can't factor, but so if you have x squared plus c, where c is a negative, so c has to be less than 0. You could have y equals x squared plus bx, and then that's always going to be equal x and x plus b, whatever that b value is. And then the most common simple trinomials are just x squared plus bx plus c, where you look and you try to find your numbers that multiply to give you the c value. They have to multiply to give you c, and they have to add to give you b. All right. So those are simple trinomials. Now, okay, so you have lots of homework to do these. I'm not going to do any more of them, but many of you will be able to do these questions without going through this game here. You'll be able to just think about it. Sometimes maybe just write down what the pairs of numbers are. So you don't have to write down that little X game if you don't want to write it down. If you can see right away, like for the second one, for this one, if you can see right away two numbers that multiply to give you positive 30 and add to give you negative 11 are negative 5 and negative 6, you can just write down the answer right away. Okay? All right, let's go. We got one more page and I think I'm done. And okay, so it says, now we'll move on to trinomials that look like they're complex. So a simple trinomial has a equal to 1. A complex trinomial has a not equal to 1. It's something else. But they're really simple trinomials that need to be common factored first. So if we take a look at this first one here, notice that all of these are divisible by 4. Common factoring is always step 1 to factoring. Okay, if you can common factor anything at all, variables, numbers, anything, you do that first. So we can take a 4 out of all this, so that's going to be a 4, x squared plus x, and then 168 divided by 4 is minus 42. Okay, so now we're looking for two numbers that multiply to give us negative 42 and add to give us 1. Think about it. Stop the video if you want. Okay, so we've got 1 and 42, 2 and 21, 3 and 14. Yeah, 3 and 14. 4 doesn't go into 42, 5 doesn't go into 42, 6 does, 6 and 7. And we're done. We want a pair that's going to add to give us 1. That's going to have to be 6 and 7. It's a negative 42, which means we're going to need positive 7 and negative 6. I'm going to sneeze. Hold on. Okay, excuse me. Okay, so our numbers are positive 7 and negative 6. They add to give me 1, and they multiply to give me negative 42. So that's going to be 4x plus 7, x minus 6. All right, try the next 3 on your own, see how you do, and then I will then come back and you'll see the answers. So this is 2x squared plus 2x plus 1. Multiply to give me 1, add to give me 2. It's going to have to be 1 and 1. So that's 2x plus 1, x plus 1. And so we can write that one as 2x plus 1 squared. This one, these both are divisible by 3, and they both have x's in them, so that can be a 3x and x plus 2, and we're done. And then the last one, these are both divisible by 5, so y equals 5, x squared minus 4. So this one, the c value is negative 4, the b value is 0. So that's going to have to be 2 and 2. One of them's going to have to be positive and one's going to have to be negative. So that's 5x plus 2, x minus 2. Okay, that's it for those. Now, just the reason why we did all this is so that we could figure out what the x-intercepts are, and then once we've got the x-intercepts, we can figure out what the vertex is by averaging and doing all the same things we did in the previous videos. So just for example, on this first one, your x-intercepts are x equals negative 7 and x equals positive 6. You could take those numbers and do negative 7 plus 6 over 2 for the vertex, which is negative 1/2, and then substitute back in 4 times negative 1/2 plus 7 times negative 1/2 minus 6. That's 6 1/2. So 6 1/2 is what? 13 halves? And negative 13 halves. And then this 4 actually will cancel out both of those 2's, and that gives us negative 169. So then the vertex is at negative 1/2 and negative 169. The x-intercepts are at negative 7 and 6, and we already know the y-intercept is negative 168. So we got all the information that we need to draw it. So that can work for all of these questions. All right, I just wanted to show you the one. Okay, we will move on to the real complex trinomials where they're not factorable. Like you can't do any common factoring. Now some of them we will be, but it'll be different, and we'll do that on another day. So this is quite a bit of work. There's some homework to do. It's listed on D2L. There's a worksheet. There's questions out of your textbook that I would like you to do. So there's lots and lots to do. We'll move on to complex trinomials maybe next week. Okay. Have a good one. And again, please email me if there's anything that we're doing and you just don't get it. There's no dumb question except the one that you don't ask. Don't sit there and just be in a fog. Let's clear the fog. Let's make it work. Okay? All right.